Hello. In this tutorial I will explain the bone mineral density calibration function of the Emalytics preclinical software. For this, let me first load the BMD calibration tutorial dataset from the tutorials menu here on the CT BMD calibration load example dataset. This is a typical micro-CT scan of a QRM hydroxyapatite phantom, and as the general information up here tells you, it is in Hounsfield units. Also, in the tutorial we already have some classes defined, but in order to show you the whole calibration workflow, I will simply delete them all and we will start from scratch. So for the phantom, we of course know the exact bone mineral density values of these rods. And what we want to do is create a class for each of these where the name is the concentration of milligrams hydroxyapatite per ccm. So let's just start with this brightest one, which is 1100 mg HA per ccm. So I simply right click, add a class, and enter 1100. It's important that the name is just this number and not any other letters or descriptions, otherwise it will be ignored by the algorithm. Now I can use the create region tool to enter some values for a cylinder that will nicely fit inside these rods. I know that a diameter of 3 millimeters and some length will work nicely here, but depending on the phantom, these values need to be adjusted, of course. It just has to be a region that is fully inside the rod and large enough to allow the algorithm to compute a good mean value for this region. So now I can click in the center of this, create the region, and that's it for the first. And I can quickly repeat this for the other rods. So add class, 800 for this next one, click. Add class, 200 for this one down here, click. 50 for this one that's barely visible, and finally 0 for the invisible one. That's more or less the background value. Before we perform the calibration, let's look at the statistics for the classes we just created. Up here, statistics, class statistics for the selected layer. Here we can see for each of the hydroxyapatite concentration classes that we created, the respective mean Hounsfield units in the cylinders that we have just created. We can export these values, for example, to Excel and then compute further information from there, which I have prepared here. So we plot the CT numbers over the hydroxyapatite concentration, and we can immediately see this nice linear dependency between the two. So by applying the inverse of this formula that comes out of a linear regression between these points, we can easily convert a CT scan from Hounsfield units to the hydroxyapatite concentration. In Emalytics, this is very easily done by simply choosing bone and create bone mineral density calibration. This will ask you now to save a file somewhere, which is the calibration file. Let's just call it calibration.bmd, and in this file the calibration constants will be saved, which are also output here again. So the resulting calibration function with a offset of 97 and a slope of 3.06. Now if we want to apply this calibration, we choose again bone and then apply bone mineral density calibration. We navigate to the file that we just saved and choose this. Immediately we can see what calibration was applied And in the background we also see that it has changed the image. And most importantly, up here in the channel information we can see that the unit of this dataset is now milligrams of hydroxyapatite per milliliter. If we take our voxel info tool over here, we can also manually check that inside this 1100 rod we have actually these intensity values. The same for all the other rods with major noise, of course. That is all. Thank you for watching. Goodbye.